Good morning, guys. Today we move on to the volume of the cylinder, and when we are talking about the volume, we need to talk about the volume of a solid cylinder and the volume of a hollow cylinder. Now let us see how the volumes of both the cylinders differ. Now this is our normal cylinder, which is a solid cylinder. Let it have a height h, so center to center height is h, and let it have a radius of r. I told you that the volume of any solid is the base area into the height of the solid, because that is the space which the solid occupies. So I have got base area into the height h. Base area is pi r square because it is a circular disc into h. So the volume of a solid cylinder is given by pi r square h. Okay. Now let us talk about the volume of a hollow cylinder. And when I am talking about the volume of a hollow cylinder, how many volumes do I have to talk about? I need to talk about two volumes. One is the volume of the solid used for making the cylinder and the volume of the cylinder itself. Wait. Hollow cylinder? Okay. Now there is a thickness for the material. Whenever you are given a hollow solid, in the examination or in any of the questions, the thickness will be mentioned to you. So this is the thickness, and because there is a thickness, and suppose this is the center, okay, from the center to the outer part I have a radius, from the center to the inner part I have a radius, correct? So I have an external radius given by capital letter R, and I have an internal radius which is given by small letter r, and my thickness is the difference between the capital R and the small r. So my T is equal to R minus R. Now all these things we have already gone through when we were doing the surface area of a hollow cylinder, but still in case you have any doubts, please listen here. Okay. Now I told you a hollow cylinder has got two volumes. One is the volume of the material used for making the cylinder. So this is my material. That material is dependent upon the thickness of the cylinder, because this is where the material has gone to. So let me find out the volume of the material used for making the cylinder. Okay. Now for this particular cylinder, I have a volume over here which is given by pi capital letter R square h. I have a smaller one over here. The volume which is again given by pi small letter R square h. Now this is the surface, correct? Okay, this is my center. Now you know that this is the thickness of the material and this space is empty. This space. Now from here to here I have capital letter R, and the smaller part is given as small letter r. Okay. Now from here to here my volume will be pi r square h, and the smaller one will be pi r square h. Now our hollow cylinder, the main problem is that this part is empty. Okay, I need to find only the volume of this part. So if I subtract the higher volume from the lower volume, I get the volume of the material used for making this particular cylinder. So it is pi r square h minus pi r square h. That is the volume of the material used for making this particular cylinder. Now, the second volume. It's a capacity of the hollow cylinder. Now, why are we having a hollow cylinder at all? We are having a hollow cylinder. The main reason being we can pour something into it. We can store something. So, what is the capacity or what is the storage space of this particular cylinder? That is not dependent upon the outer radius, because the outer radius is blocked by the inner radius. Correct? So, that volume is decided only by the inner radius, and that volume is given by base area into the height of the cylinder. Okay, so that is dependent upon the inner radius. Now when I said in the case of a hollow cylinder, the thickness will be given to you. Sometimes instead of the thickness, they give you both the internal and the external dimensions, or internal and the external radii. So you can find the thickness from that also if they are asking for the thickness. Or sometimes what they do is that they give one of the radius and they mention the thickness. So accordingly, using this equation, find the other unknown. Okay. Now let us move on to a few sums so that you get clarity about these formulas. The circumference of the base of a cylinder is 132 centimeter and the height is 25 centimeter. Find the volume. Now all the units are given are in centimeters, so I don't need to change anything. Now the circumference of the base is given. So you know circumference of the base is 2 pi r is given as 132. Height is given as 25. We need to find the volume. Volume is given by pi r square into h. So I know the value of h, which is 25 centimeters. I know the value of pi. I am not aware of the value of radius. So I can find the value of radius from 132. So what do I get? I will get r is equal to 132 by 2 into 22 by 7. I will get it as 147 by 2 centimeters. You will get the value of radius as 21 centimeters. Now you have got all the values required for finding out the volume. So substitute in the formula and find out the volume. Now let us go on to the next sum. The thickness of a cylinder is 2 centimeter. The inner radius is 12 centimeter and it is 35 centimeter long. Find the volume of the wood required if the cylinder is open at both the ends. So now you have a cylinder like this. It's open at both the ends. Now when we are having the sum, I told you first check the units. Everything is in centimeter. I don't need to change anything. Now let us write down the data that is given to me in this particular question. So the thickness of the cylinder is given to me. The inner radius is 12 centimeters. So in the question, it is not particularly mentioned if the cylinder is a hollow cylinder. But since the thickness and the inner radius is given, you have to understand that it is a hollow cylinder. So segregate the concept related to the hollow cylinder. The thickness is given by outer radius minus inner radius, which is given as 12 centimeter. Sorry, 2 centimeters. The inner radius is given to be 12. So I know that my outer radius is 14 centimeters. Okay. I know that the height is given to be 35 centimeters. Now I need to find the volume of the wood required. You know that the volume of the wood required is given by pi, capital letter r square h minus pi. Because pi and h are common in these two terms, I will be taking it out because I don't want to keep multiplying with it each and every single time I am approaching this particular question. So 196 minus 144. So I will get 22 into 5, 52 or 110 into 52. So I will be getting 5720 centimeter cube. That is the volume of the wood required for making this particular cylinder. The volume of a cylinder is given to be 448 pi and the height is 7. So we have to find the lateral surface area and the total surface area. So this is the volume plus area sum. So we need to check the units. Everything is in centimeters. So I can safely start the sum. Let us write down the data that is given to us. We know that the volume of a cylinder is 448 pi. So we know that the volume formula is this. Okay, height is 7 centimeters. So now if you substitute it in the formula, you can find out the value of r square. Pi and pi will get cancelled. So you will get 448 by 7. So you will get it as 7 6 or 42, 7 4. 64 centimeters, or I can say that my r is 8 centimeters. So we have gotten the value of the radius of the cylinder, and because it is a normal cylinder, not a hollow cylinder, there is only one radius. Find the LSA and the TSA. Now you know that lateral surface area of a cylinder is given by 2 pi r into h, and the total surface area is given by this particular 2 pi rh plus 2 pi r square, which is the area of the two bases, which are base and the top face and the bottom face, basically speaking. So substitute the value and get the answer. It's basic multiplication. You people can do it. So I will move on to the next one. If the radius of the base of a right circular cylinder is halved, keeping the height same, find the ratio of the volume of the two cylinders. Now, no particular measurements, no numericals. It is just finding out the ratios. So let us take the original cylinder and the new cylinder. Okay. Now the radius of the base of a right circular cylinder is half. So if the radius of the original one was r and the height was h, the radius of the new one is r by 2 and the height is kept the same. Okay. Now we need to find the ratio of the volume of the two cylinders. So what is the volume of the original cylinder? Pi r square h. What is the ratio? What is the volume of the new cylinder? Pi. Right. Now I need to take the ratio, means I need to divide both of them. I can cancel out the common factor. So pi and h will get cancelled. So what I am getting is r square by 4, or I will get 4 by 1. So the ratio of the original cylinder is 4 times as that of the previous cylinder. Okay. Suppose in the same question, instead of keeping height the same, I am making the height 3 times as as more than the original, or 3 times the original height. So if the radius of the base of a cylinder is half, keeping and height thrice the original one. Okay. Find the ratio of the volume. So let us see what is the ratio that we are getting. So in this particular one, the original one has radius r and height h. Now the new one has a radius of r by 2, but the height becomes 3h. Because the new cylinder, the height has become thrice the original. Now if I take a ratio, this is pi r square h, this is pi r by 2 the whole square into the height of this particular cylinder. Now I am dividing pi r square h by pi r by 2 the whole square into 3h. Right? Now let me cancel. Pi and pi get cancelled. H and h get cancelled. So r square by 4 into 3, or r square and r square get cancelled. It will become 4 by 3, or 4 is to 3. So I can say that the volume of the original cylinder and the new cylinder are in the ratio 4 is to 3. So it does not matter what is the ratio of these particular terms or measurements that are given to you. This kind of sums are very easy. You just need to make clear that you find the volumes of each of them correctly. Okay, so you can work out the sums on your own. Instead of making the radius half, you can double the radius and you can make the height into half and see what is the new ratio that you are getting. Try it out with your friends, cross check the answers and see if you are getting the correct answer. A cylinder has a total surface area of 462 square meter. Its curved surface area is 1/3 of the total surface area. Find the volume. Because I was too lazy to write curved surface area and total surface area, I have written TSA and CSA. So you guys understand anyways, right? So here I have got TSA is equal to 462 centimeter square. So TSA is given by 2 pi r square plus 2 pi r h. This is 462. Now CSA is 1/3 of the TSA. So CSA is given by 2 pi r h. 2 pi r h is 1/3 of 462. Okay, what are we getting? 154. Okay, 154 centimeter square. Okay, now if I am substituting 154 in this particular equation, I will get 2 pi r square is equal to 462 minus 154. You will get a 308 and I can find the value of r square by dividing it with the 2 pi. And I will get the value of r as 7 centimeters. Now I know the value of r. Okay, so if I am substituting, what do I need to find? I need to find the volume, so which is given by pi r square h. Now I need to find the unknown value of h. I know the value of r, and we also know that 2 pi r h is equal to 154. So I will be getting, okay, I'll do it here. 2 pi r h is 154. I know the value of r is 7. I can find the value of h. right? So when I'm solving, I will get 154 by 2 into 22. 7 and 7 gets cancelled. So here I will be getting 77 by 22, which is 7 by 2, or I can write it as 3.5 centimeter. So I have gotten the value of R, I have gotten the value of H. You can substitute it in the formula for volume in order to get the required value. When you substitute it in the value of, the formula for volume, you will get pi r square h 22 by 7, r square we already know, and the height is 7 by 2. You will get the final value as 539 centimeter cube. How many cubic meters of earth should be dug out to sink a well of depth 22.5 meters and diameter 7 meter? Also find the cost of plastering the inner curved surface area at the rate of rupees 10 per meter square. Now this question has two parts. The first part is you have to find how many cubic meters of earth should be dug out, and the second part is the cost of plastering. Now a person who has understood the concept of area and volume will understand from this particular sum that the first part deals with volume and the second part deals with area. Now, if you are a student who has not understood yet as when to find volume and when to find area, there is an easy way of finding it out. Look at the unit. Cubic meters, which is this, deals with volume. Meter square deals with area. So, in the second part you want to find area, and in the first part you need to find the volume. Okay. Now, if you're not able to figure out volume or area, or if you're too tense during the examination, don't break your head. Look at the unit. Unit is the best way of identifying whether you need to find area or whether you need to find volume. Okay. So, now let us deal with the first part. How many cubic meters? What's the volume of the earth that should be taken out to sink a well of depth 22.5 meters? So, if this is a well and this is the earth over here, earth needs to be taken out from here. Okay. So here everywhere it is earth or soil, basically you are taking it out and you are having a well over here. They are telling you this depth is 22.5 meters. A well is in the shape of a cylinder. A water tank is in the shape of a cuboid. A canal is in the shape of a cuboid. But a well is in the shape of a cylinder, unless they mention it's a square well. Okay, whatever. So height is 22.5 meters. Okay. Now the diameter is 7 meter. This is 7 meter. So my radius is 7 by 2. So what is the volume of the soil that is taken out? It is pi into r square into h. Now guys, please write the formula always, every single time you do a sum, because the formula or mention of the formula carries mark. Okay. Now this becomes 22 by 7 into 7 into 7, 2 into 2 into 22.5. So, okay. You know why I have written 225 by 10, because I need to work with fractions. So please do the calculation and see what you are getting. So I am getting 495 into 7 by 4. Okay. Now, you know that for neither 495 nor 7 is divisible by 4. You will get a decimal definitely, right? Now, sometimes what happens is that the student, or you guys anyways, divide 495 by 4, which will give you a decimal. Then you multiply that by 7. Now, the problem is that if this division is not a terminating one, suppose it goes on like 0.3333, something like that, you have to approximate it, and that approximation is multiplied 7 times. So though you get an answer close to the correct answer, there will be some amount of deviation from the answer. Now how much of deviation is allowed in your particular answer sheet or with your particular teacher, I have no idea. So always when you feel that the denominator cannot divide the numerator properly, multiply the numerator completely. So I would multiply 495 and 7 and then divide by 4. These are small things that you should take care of when you are doing calculations. Okay. So you will finally get the answer as 866.25 meter cube. Now let us move on to the second part. The cost of plastering the inner curved surface at the rate of so and so. So this is my inner curved surface. So cost of plastering is always related to area, painting is always related to area, cementing is always related to area. So I told you the inner curved surface is this surface. So let us see what is the radius or what is the area of the inner curved surface and the cost of plastering. Now you are asked to find the inner curved surface area for plastering. So when it is plastering or when it is painting or cementing, we always deal with the area. So now the curved surface area of this particular cylinder is given by 2 pi RH. Though they mention inner curved surface area, there is no question of outer curved surface because it is a well, it is in the soil. Okay, so the formula is 2 pi RH. So I have done the calculation over here and the cost is inner curved surface area into 10. Find out the final value of the cost. A well with 10 meter internal diameter is 40 meter deep. Earth taken out is spread all around to a width of 5 meters to form an embankment. So find the height of the embankment. So now first you need to know what an embankment is. It is basically the wall that is built around a well so that you don't fall inside. Okay. Now normally the well that we normally see are the wells which are dug on the ground. So basically the soil is taken out to a great depth so that you see water beneath, and then it's a source of normal or natural water, and then the soil taken out is kept along the wall because there's a huge hole on the ground. So there is a wall around the well so that anybody who is drawing water from the well do not fall inside. It's a basic safety precaution. So it is said that in this particular sum, the earth that was taken out of the place in order to build the well, that soil was used to build the embankment. Basically, the volume of the soil or the quantity of the soil that was taken out was utilized in order to build that particular wall. So we have to find out the volume of the soil that was taken out and the volume of the soil that was used to build the particular wall. Okay, and equate both of them. So let us see how we can do it. Now, you know that the amount of soil from the well, in order to find that, we need to find the volume of the well, because the volume of the well is actually gives you the soil that was taken out, right? So that is pi r square-ish, because the well is a cylinder, you will get it as 1100. Now that amount of soil without any wastage was used for making embankment. So 1100 meter cube of soil was used for making the embankment. Now, what is the volume of the embankment or that particular structure? Volume of the soil used is basically equal to base area into height. Okay. Now, area of the base into height. Now, let us find the area of the base. Okay. Now, I have drawn a diagram, an exceptionally bad diagram, but I think for understanding the basic structure of the sum, this is enough. So, this is our well, which is filled with water. This is all earth all around. Okay. Now, this is our level or the ground level, you can say. This is the embankment, which is built for safety purposes. Now, I cannot cover the entire wall with embankment like this, because then the well will not be of any use to me. So, I have to keep a gap over here, which is a circle. So, what do I get? I don't get a complete circle. I get a circular disc. Here you have the well. Okay. This is the inner diameter of the well and this is the outer diameter of the embankment. Now, what is given to us? Inner diameter of the well is the same as the inner diameter of the embankment, because it is around the well. So, that is 5 meters, 10 by 2. Now, it is given that the embankment is of a width of 5 meters. So, I can say that this thickness is 5 meters, so that my outer radius is 10 meter. The area of the base is outer area minus inner area, because the center part I don't have to take. It is like a hollow cylinder. So this is what I am getting. I am not getting a proper value, but so because I am leaving it as a fraction. Okay, and I need to find the height of the embankment. Now this area into height is equal to 1100 meter cube. Equate both of them and find the value of height. Let us see what we are getting. So when you equate that particular area into height equal to 1100, height is equal to 1100 into 7 by 22 into 75. After cancelling out the common factors, I am getting 14 by 3 meters. So it is approximately equal to 4.667. So when you please do the calculation yourself and cross verify the answer. So always understand that a well is in the shape of a cylinder and the embankment is like a hollow cylinder. Please keep that in mind whenever you get a sum related to this. Okay. So this is a sum from the NCERT textbook. It is about a lead pencil and consisting of wood and graphite, and the graphite part is pushed into the wood, and the measurements of the diameter of the pencil, diameter of graphite, and a few other measurements are given to you, and you are asked to find the volume of the graphite, volume of the wood, and the weight of the whole pencil. Okay, and specific gravity is also given to you, which is a relatively new term for you guys as far as maths is concerned. Okay, so now you know every pencil, there is wood and inside that there is graphite. So you can see here there is wood and in the center you have got graphite. Now this graphite part extends along the pencil. So the length of the wood and the length of the graphite both are the same. So I can say that length of the pencil is the same as the length of the wood. It's the same as the length of the graphite. Okay. Now, so guys, you can see that I have again drawn a very weird diagram, but this is a pencil and the wooden part and the graphite part all along the pencil. This is in the form of a cylinder and the outer surface is also in the form of a cylinder as mentioned in the question. Now, what is given to us? The diameter of the pencil is given to us. Diameter of the pencil is given to us as 7 millimeter. Diameter of the graphite is also given to us, which is 1 millimeter. I have drawn it separately because I don't have place to mark. So this is 1 millimeter. Okay. Now the length is given as 14 centimeters. I am going to convert it into millimeter, and at the end of the sum, I will convert it into centimeters or meters. However, you expect the answer to be. But right now I am going to go with millimeter. So 140 millimeters. Now, the first part is to find the volume of the graphite. Now, okay, the graphite is in the form of a cylinder whose volume is given by pi r square h, which is 22 by 7 into radius of the graphite part, that is 1 by 2 the whole square into 140 millimeter. Okay. Now let's find out the answer for this. You will get it as 22 by 7 into 1 by 4 into 70. Sorry, into 140. Now I will be cancelling. This is 20. This is 5. So I will get the answer as 110 millimeter cube. Okay. Now in order to convert it into centimeter cube, you have to divide it by 1000. So you get 0.11 centimeter cube. So the first part was very easy, directly a cylindrical shape, and you know the radius and you know the height, substitute. Second part, we need to find out the volume of the wood. Again, the wooden part is also in the shape of a cylinder, but is the formula a direct substitution of the values? Let us see. Now, this is the surface of the pencil, the outer surface of the pencil. It is cylindrical, right? Now, here you have a graphite part. You have a radius here, which is the radius of the graphite. Here you have an outer radius, which includes the radius of the graphite plus the radius of the wood. Okay, that is given to be 7 by 2 because 7 millimeters the diameter, 7 by 2 becomes the radius, and this becomes 1 by 2. Okay, what do we need to find? We need to find the volume of the wood in the pencil. Volume of any object is given by base area into height. The base is in the form of a hollow cylinder concept where you have to take the outer radius minus the inner radius, or outer area minus the inner area, because this part is graphite. In the case of a hollow cylinder, this part is hollow. So in order to find, we subtract the outer area minus inner area. Here we have graphite. We don't need it. So it is outer area minus the inner area. So now let us see what we are getting. So here I have done the volume of the wood. It is always the base area into height. Now the base is in the form of a disc where you don't have to take the area of the graphite. So outer area minus inner area into the height. Substituting the values, you will get 5280 millimeter cube. Please do the calculation by yourself and then recheck. To convert it into centimeter cube, divided by 1000. So you will get 5.28 centimeter cube. Okay. Now let us move on to the third part. The third part, we need to find the weight of the whole pencil if the specific gravity of the wood is 0.7 and that of graphite is 2.1 gram per centimeter cube. Now, specific gravity is a new term. So, you might come across terms like that in this particular chapter. Now, whenever you are faced with a new term, now specific gravity is basically a relative density. It is basically density of an object with respect to density of water, but that is physics. You don't have to bother about that part. we need to bother only about the formula part of it. So now, if you do not know the formula of specific gravity, what you need to do is that, look at the value that is given to you. It is 0.7 gram per centimeter cube and 2.1 gram per centimeter cube. So what they have given is a numerical value with the unit of weight by volume. So my specific gravity is basically weight by volume. So what do we need to find? We need to find the weight. Weight is equal to specific gravity into volume. Okay. Now we know the formula. Now let us find the weight of the pencil. What is the weight of wood? It is a specific gravity of wood into the volume of the wood. Volume of the wood we found out in the second part. It is 5.28. That is it. Now weight of the graphite is specific gravity of the graphite into volume of the graphite. Now the total weight of the pencil will be the sum of these two. Do the calculations, figure it out by yourself. What is the answer you are getting? So the basic thing is, whenever you are getting a new term, if you are not able to identify the term or you do not know the formula, do not panic. Look at the unit and derive the formula. Okay. Now we are winding up the chapter. If you have got any doubt in the contents of this chapter, mail me at the mail ID given below in the description box. Before I wind up in chapter, I have come across another sum which I found to be a really good sum. So let us do that sum and then wind up the chapter. Okay. From a tap of inner radius of 0.75 centimeters, water flows at the rate of 7 meters per second. Find the volume of water in liters delivered by the pipe in 1 hour. So you know that the amount of water that is delivered is equal to the volume of the water or volume of the pipe which is delivering the water. Now let us find the volume of water. Now you know that it is not still water, it is flowing water. So you know what you should do with flowing water. You need to take the distance covered by the water. Okay. So now we have the radius of the pipe as equal to 0.75 centimeter. I am going to keep everything in centimeters. So I will get 3/4 centimeter. I converted this into fraction. Now water flows at the rate of 7 meters per second. Now you have a pipe and there is water flowing. You know that velocity is equal to distance by time. I told you that for flowing water, the length is always given by the distance. Okay. So my distance is equal to velocity into time. What's the time that is mentioned in the sum? 1 hour. 1 hour is how many seconds? I'm going to convert everything into seconds and everything into centimeters. So my seconds, my time will be 1 hour into 60 minutes into 60 seconds. My velocity is 7 meters per second. 7 meters is actually equal to 700 centimeters. Now I am getting the height as equal to this particular value, which is 700 into 600. Okay. Now I need to find the volume of the water in liters. So before converting it into liters, let me find out the volume of the water in centimeter cube. So pi r square h. Okay, here I have made a mistake. 60 into 60, 3600. Okay. So this is 22/7 into 3/4 the whole square into 700 into 3600. This is the volume of the water in centimeter cube or volume of the pipe in centimeter cube. Now let us see what we are getting before we convert it into liters. Okay guys, so 22/7 into 3/4 the whole square, I have written it as 3 into 3/4 into 4. 700, I have split it into 7 into 100. The reason being, because there is a 7 over here, I can easily cancel. You can write it as 700 and cancel. It's your wish. And 3600. Now 7 and 7 gotten cancelled. 4 and 100, you get a 25. 4 and 3600, you get a 900. Now 22, 3 into 3, 9 into 25 into 3600. Okay, sorry, into 900. Now I have split. Now you can multiply directly over here. You know, 22 into 9, you can find out, then multiply it by 25, then multiply it by 900 and find out the final value. You will get the correct answer. But in order to simplify this calculation, see, when I'm having a number 22 into 9, 9 into 18, 198 into 25, I need to write like this and I need to calculate. So whenever I am doing this, I try to avoid such calculations because it tires me out. So what I do is that I split the numbers. 22 into 9 is 3 into 3, 25 is 5 into 5, and 900 is 9 into 100. The reason I am doing it is because I want to bring in as many 5s and as many zeros as possible. Okay. Now, 22 and 5 I have multiplied, I get 110. 3 3s, I again keep it as 9 because I see that even if I keep it as 9 or 3 into 3, it won't make a difference. I return the 5, then I have a 9 and then I have 100. Then this 110 and the 9 I multiply. So I get 990 into 5 into 9 into 100. Then I multiply the 5 and the 990. I get a 4950 into 9 into 100. I multiply with a 9 and this is what I'm getting. So I get the final answer as 4455,000 centimeter cube. In order to convert it into liters, I need to divide it by 1000. So my answer would be 4,455 liters of water. I hope you have understood. Now this calculation part is entirely left to your convenience. This is the way that I work with my calculations. So I just showed it. In case you find it more comfortable or easier, you can please adopt this method. But then when you are doing it, you need to do it for each and every single sum, or wherever possible, you need to do it so that you get a hang of it. Okay.